For the next property you are going to learn is the frequency shifting property. Okay, last time you learned about the time shifting property. In time shifting property, the shift takes place in the time domain. In frequency shifting property, the shift takes place in the frequency domain. Okay, so let's look at the property. If Laplace transform of x of t is equal to x of s, then the Laplace transform of e raised to minus at into x of t is equal to x of s plus a. This is the frequency shifting property. Okay, that is the Laplace transform of e raised to minus at x of t is equal to x of s plus a. Here if you look carefully, this is the opposite of frequency shifting theorem. That is, in frequency shifting theorem, the shift occurs in the time domain and the exponential function is multiplied in the frequency domain. Here it is opposite. Here the exponential component is multiplied in the time domain and the shift occurs in the frequency domain. That's why this is called as frequency shifting. The frequency is one is being shifted. Okay, but that is not the only difference. Another important difference is that if you look at the value of the power, here it is e raised to minus a, right? E raised to minus at. So that means the power, the constant over here, the power, the constant of the power is minus a. If it is minus a over here, then the shift takes place in the opposite, in the opposite value of this. That means here it will be replaced with plus a. Okay, this is also another important difference between time shifting theorem and frequency shifting theorem. In time shifting theorem, if the shift is by minus a, then the power of the exponential in the frequency domain is also minus a. But here it is opposite. Here if the power in the time domain is minus a, then the frequency shift is opposite of that. It's the plus a. Okay, this important difference you have to remember. This is where everybody usually makes mistake. Some of the write e raised to minus at x of t is equal to x of x minus a. That is wrong. Okay, if it is here raised to minus at over here, then it should be replaced with over here, then s must be replaced with s plus a. Okay, so here's the proof. If the Laplace transform x of t, we all know is integral minus 50 plus 50 x of t into e raised to minus st dt. Okay, so now I'm going to find the Laplace transform of this. Okay, the Laplace transform of this means all you have to do is simply replace this with x of t. Okay, so that is what you see over here. That means this will become, the Laplace transform of this is integral minus 50 plus 50 e raised to minus at x of t into e raised to minus st dt. Okay, so now I'm going to combine these two exponential functions. This will becomes e raised to minus of s plus a into t dt. Okay, so this basically looks like a Laplace transform. With the only difference is that instead of e raised to minus st, it is e raised to minus s plus a. In other words, this equation becomes a function of s plus a. So that means instead of x of s, this becomes an x of s plus a equation, right? This becomes a function of s plus a. So this is how we got the frequency shifting theorem. Okay, so that means always remember this equation. In other words, if I'm going to make the sign change, the frequency shifting theorem can also be defined as the Laplace transform of e raised to plus at into x of t. Okay, the Laplace transform of e raised to plus at into x of t is equal to x of s minus a. You see, so here if the power is negative over here, then the shift is positive. If the power is positive over here, then the shift is negative. Okay, so now let's do some problems regarding this Laplace transform. Yes, let's do this problem. Okay, this problem can we have not derived the formulas of these four equations, but these four equations we can derive it easily by applying the frequency shifting theorem. Okay, so in the first case here, the Laplace transform of e raised to minus at cos ohm 0 t. So this is a unilateral Laplace transform, so I can write it like this into u of t. Okay, into u of t. Alright, I have to mention that it's a unilateral Laplace transform, or if I'm using it as a normal Laplace transform, then I have to multiply the signal with u of t. Okay, so this is my Laplace transform e raised to minus at cos ohm 0 t u of t. Okay, so we know that the Laplace transform of of cos ohm 0 t u of t is equal to s by s square plus ohm 0 square, right? This is my Laplace transform of cos ohm 0 of t into u of t. In that case, on applying the according to frequency shifting theorem, here it is multiplied by e raised to minus at, right? We know that according to frequency shifting theorem that the Laplace transform of e raised to minus at x of t, this is my x of t, is equal to is equal to x of s plus a, x of s plus a. So here my x of t is cos ohm 0 t into u of t. This is my x of t, right? So in that case, then my x of s plus a is nothing but replacing every s that you see here with s plus a. So in other words, this becomes the Laplace transform of e raised to minus at cos ohm 0 t into u of t is equal to, so I'm going to replace it, here it is minus a, so it should be s plus a. So wherever you see s over here, you replace it with s plus a. I can see an s over here and I can see a s over here, so replace all that with s plus a. So it will become s plus a by s plus a the whole square plus ohm 0 square. Okay, this can also be used as a formula. Okay, this can also be used as a formula, and even if you can't remember the formula, it's okay. This is nothing but applying the frequency shifting theorem of your previous formula, that is Laplace transform of cos ohm 0 t into u of t. Okay, if you can remember this, then writing this will be also be very easy, right? This is what basically frequency shifting theorem means: replacing s with s plus a, or replacing s with s plus the opposite value of the power of the exponent. Next question. Here you should find the Laplace transform of e raised to minus at sine ohm 0 t, right? We all know that the Laplace transform of sine ohm 0 t, sine ohm 0 t is ohm 0 by s square plus ohm 0 square. Okay, so now in that case, the Laplace transform of e raised to minus at sine ohm 0 t, by applying the same frequency shifting theorem that you see here, x of s becomes x of s plus a. That means replace every s that you see here with s plus a. So this equation becomes ohm 0 by s plus a the whole square plus ohm 0 square. Okay, now you can pause the video and find the Laplace transform of the remaining two questions that you see here. Okay, and see if you are getting the correct answer. Okay.